Let's consider the following graph. And suppose we want to find a shortest tour for this graph. And in order to help with that, we first find a minimum spanning tree for the graph. So let's mark the edges that are part of the minimum spanning tree in purple here, like so. So if you were to take a tour along this minimum spanning tree, let's say starting at A, you might do something like this. Starting at A, then through D and G and back to D, through E, through H, back to E, B, C, F, and then all the way back along the route, back up to A. So maybe you can see that there are some redundancies in this tour. For example, we go to D, back down to G, and then back up to D. So instead of going along this tree route, let's optimize a bit. Let's, instead of always following the minimum spanning tree, let's compute this tree route first, but then, instead of following it, we look at the next vertex in the tree route that we haven't gone to yet, and we take the shortest path there. So for example, we would start out at A, and then the next vertex along the path is D, so we go there, and then G, so we go there. But then the next vertex that we haven't visited yet along the tree path is E, not D, and we can go there just by short-circuiting here. So we cut D out and go straight to E. Then we'd go to H, and again, the next unvisited vertex along the tree path is B, not E. But there's no shorter path than this from H to B, so we would still follow it in this case. Then C and F would still be unvisited, so we would follow them exactly. But then the next unvisited vertex, well, is all the way back at A, since we'll just say that the first vertex is unvisited. Well then, what we really want is the shortest path from F to A, not necessarily along the tree route. And you can see that shortest path is actually along up here. So instead of following this tree path, we have a slightly shorter tour that sticks close to the tree path but doesn't necessarily follow it exactly. Now, my questions then are, what percentage improvement do we get in this tour versus the original tree path? And second, what approximation factor do we achieve in this specific instance? Now remember, in order to figure out the approximation factor, you'll need to calculate the optimal tour length for this graph. Please input your answers in the two boxes.